Hey everybody, we are in chapter 1, still looking at variables and expressions. Today we're going to talk about section 1-2, which is order of operations. We have two vocabulary terms. One is to evaluate and the other is order of operations, and we're going to look at it on the next two screens, the definitions on the next two screens. So the first one, to evaluate, is really just to find the numerical value for a numerical expression. So you can get a problem that looks like this: 3 plus 7 times 4, and you would need to evaluate that. Find out what this means. Well, I'm going to give you a hint. Order of operations tell me I need to use multiplication first. That comes before. And so this really is 3 plus 28, which we can simply add to get 31. So we have evaluated this numerical expression. The next the next thing we need to remember and recall is order of operations. How do we organize our operations? How do we know what to go first? What to do first? First thing we're going to do is what is in parentheses. The next thing we're going to do is, if there are any exponents, we're going to do that, do whatever operation we need to do exponents for, exponents. The next thing is multiplication and division. Sorry about that. And we know that these are equivalent operations, and we just do it from left to right. We do not say multiplication supersedes division or division supersedes multiplication, but we go from left to right. And the final thing we're going to do is addition and subtraction, and these two are also equal operations. And that goes from left to right, okay? So keep that in mind when you are processing through your problems. And oftentimes we use PEMDAS or please excuse my dear Aunt Sally as a mnemonic device to memorize this. So keep this in mind as we go through the next set of problems. So we're going to evaluate the following expressions. These are pretty straightforward. Evaluate each of the expressions. These are all just raised to a power. So this is 3 to the 5th power, 2 to the 4th power, 7 to the 3rd power, and 4 to the 5th. 3 to the 5th power means that I'm multiplying 3 by itself 5 times. And when we do that, we get 243. What I'd like you to think about if you had to do these is multiply 3 times 3, you get 9. 3 times 3, you get 9. 9 times 9, you get 81. Then it's easy when you're multiplying 81 times 3, okay? 2 to the 4th power, similarly, let me use a different color so we don't get confused. 2 times 2 times 2 times 2, and we know that that's 4 times 4 if we take the 2's here and 2's here, and 4 times 4 is 16. So 2 to the 4th power is 16. 7 to the 3rd power is 7 times 7 times 7, which is 49 times 7, which is, think about it, Dion, 7 times 63, 28, 343 is what I should have gotten after all of that grumbling. All right, so we get 343. And our final one is going to be 4 to the 5th power. And I think you guys have gotten hold of how we're going to do it. We're going to multiply 4 times itself 5 times, and we'll get, and I think that's 1,024. And I know you guys will let me know if I've made a mistake, so I'm cool with that. All right. Any questions about this? Let me know. But that was pretty straightforward evaluation. We're going to now, this example too, we're going to evaluate some more expressions, but this time we're going to use order of operations. So we need to keep our heads about us. What we're looking at is a whole lot of stuff going on. So here, I'm going to rewrite this so it looks a little bit more like what your textbook has. There. So when you have a problem written out like this, you need to keep in mind order of operations. So I'm thinking parentheses, don't have any. Exponents, I do have that here. So I'm going to write 16 minus 8 divided by, handle the exponents, 4 plus 14. Again, I'm still thinking about order of operations as I want to complete this. It's so common. I mean, I don't know how many times I'll teach it and then people just go, oh, I'm going from left to right. No, 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 no. You need to make sure you keep in mind the order. So the next thing we need to do is division. So 16 minus, what is 8 divided by 4? 2 plus 14. And now, since I'm left with addition and subtraction, and we know that those are equivalent expressions, we just go from left to right. We don't take this first and then go, okay? So 16 minus 2 is going to give me 14, and then 14 plus 14 will give me 28. So my final answer is 28. All right? Hopefully that wasn't too bad. Let's look at this next one. I'll do another rewrite. So this expression is 3 plus 42 times 2 minus 5. What we need to do is follow order of operations. No parentheses, don't have to worry about it. Any exponents, not so much. Multiplication and division, yup. We've got multiplication right in the center here. So this is going to be rewritten as 3 plus. Notice everything else stays the same, but I'm going to handle the thing that is most pressing, and this time it's multiplication. 42 times 2 is going to give me 84, and then I have the 5. Again, precedence. There's no precedence between addition and subtraction. They are equivalent operations. So I'm going to go from left to right. 3 plus 84 is 87, and then when I subtract 5 from 87, I do believe I get 82. And that's my answer there. And let's do this final one again. Let's do a quick rewrite. So we have 20 minus 7 plus 8 squared minus 7 times 11. So again, going through our mental Rolodex, parentheses, nada. Exponents, yep, right here. So that thing takes precedence. I'm going to do that first. 20 minus 7 plus 64 minus 7 times 11. Next, multiplication and division. Is that a part of this problem? Oh yeah, it's right here. So I'm going to deal with that. Everything else stays the same. Everything else stays the same until I do the thing that took precedence. The next thing I'm going to do is recognize that everything here is just going from left to right, addition and subtraction. They're equivalent. So I'm going to do that, and I'm going to just go from left to right. 20 minus 7 is going to be 13. 13 plus 64 is going to be 77. 77 minus 77 is 0. All right? So those are my answers. Please let me know if I made a mistake. I'll happily change it and credit you for it. All right, let's look at this last one. Example 3, expressions with grouping symbols. So now we've added the parentheses into the mix, and now we're going to see how parentheses can affect. Couple things I want to tell you real quick. First of all, okay, so this is, let me rewrite, 4 divided by 2 plus 5 times the quantity of 10 minus 6. Notice I said 5 times the quantity. This means when there's no sign given here, this definitely means multiplication. So we are multiplying this stuff here. We don't have to use distributive property, which we've talked about last year, because right now we can simplify what's in the parentheses. So I'm going to do just that. Parentheses first, got it. I'm going to deal with that. Everything else stays exactly the same. 10 minus 6 is going to give me 4. When I've got two numbers like this side by side and there's no operation symbol given and there's parentheses specifically around 1, that means multiplication. So I've got division, addition, multiplication. What supersedes what? The division and the multiplication do. I'm going to do all the division and multiplication left to right. So 4 divided by 2 is 2 plus 5 times 4. I should have did 5 times 4. Sorry, chablitos. For me, I'm very confusing. Okay, sorry about that. Get back to the, okay, 5 times 4, 20. So I did the division and the multiplication left to right just as it is. And finally, I get the answer 20 because I'm just going to do the addition. Got it? Good. All right, let's do this next one. Ooh, here we've got 2 grouping symbols. We've got parentheses, and then we've got super parentheses. Those are really just brackets, but sometimes I call them super parentheses because they kind of have the same power. So if I'm walking down the street and I see this problem, I know the first thing I need to do is what's in the brackets. And then within the brackets, I'm going to go to the first thing that I need to do, which is what's in the parentheses. And then I'm going to do what's in the parentheses, and I'm going to kind of work my way out. Got it? Okay, let's do. I'm going to do a quick rewrite. So 6 times the quantity of all of this stuff up in here is basically what we're looking at. So again, there's multiplication out here with that 6, and we're going to save that for later last. So as I look at this, I'm going to rewrite. I'm going to do what's in the parentheses first in the inner parentheses, and that's going to change this. The rewrite for this is going to look like this. 5 quantity squared right there. And the next thing I'm going to do is now, are there any other parentheses? Yes, but there's nothing to do in here. Yes, these are technically parentheses, so I need to deal with that. But when I deal with that, that means go in and deal with the stuff within. So within this thing here, I see that I've got an exponent. So exponents are important, more important than subtraction. So I'm going to take care of that. So rewrite looks exactly like this. And then I'm going to subtract 32 minus 25 because still I've got to do what's in the parentheses first. 32 minus 25 will give me 7. And I'm left with 6 times 7. I threw that little dot for multiplication. You can do that or you cannot. 6 times 7 is what this means, and we know that the answer to that is 42. Let's do this final problem that is weirdly written. I will rewrite it for you so it looks a little bit better. So this is supposed to be 2 to the third power, subtracting 5, all of that over 15 plus 9. Here's a little hint. Whenever you have a division sign that is a fraction, like a fractional division sign, know that it automatically throws parentheses around the numerator and the denominator. So what that means is you cannot divide until you simplify the numerator as much as possible and simplify the bottom part, the denominator, as much as possible. Super duper important, and if you don't remember, it will get you every time. So I'm going to deal with the numerator first. 2 to the third power is 8. 2 times 2 times 2, yep, 8. So this becomes 8 minus 5. Why am I doing this? I need to do what's in the parentheses first. What's in the parentheses right here is exponents, which takes precedent. So I've got that, and at the same time, I can look at this denominator. 15 plus 9 is going to give me 24. So I can hold on to that. I'm going to work my way over here. I'm going to simplify that. 8 minus 5 is going to give me 3 over 24. This is reducible, and so I get 1 over 8. So my final answer is 1 over 8. The take home with this type of a problem is to recognize that this was supposed to be one problem. I know it looks crazy. I was really having trouble with the computer at the time. The take home with this is that you need to make sure and know that you need to simplify the top and the bottom before you get started doing anything else with these problems. All right? All right. This is the last one. No, it's not. We partying today. All right. Example 3, expressions with grouping symbols. Again, this is very similar. Oh no, I get it. I'm sorry. I made these a long time ago, and I did not expect to do all of the work like kind of jacked up all here tight together. So, Chavalitos, I think we are almost done. This is our last, I'm sorry, thank you so much for being patient. This is our last one, promise, promise, promise. Okay, so example 4, evaluate the algebraic expression. So here is an algebraic expression where we've got 3 times x squared plus the quantity of 2y plus z to the third power. They ask us to evaluate this if we are given these values to substitute right in. And what we're going to do is do exactly that. So since x is equal to 4, I'm going to write this as 3 times 4 to the second power plus 2 times y is 5. I'm going to put a 5 right here, plus z. What is z? 3. Okay, 3 to the third power. And now I've rewritten it. So I've gone from an algebraic expression, notice all the variables, to just a numerical expression, no more variables, and I'm going to evaluate it using PEMDAS. And so I'm going to do my thing. So this is going to be looking from left to right. I need to handle what's in parentheses first, so everything else gets a rewrite. And I'm going to start working on the inside. On the inside, I've got an exponent, an addition, and multiplication. I'm going to take care of that exponent first. So I get 2 times 5 plus 3 to the third power, which we know to be 27, and I close parentheses. Within the parentheses, the next thing that takes precedence is that multiplication. So this becomes 10 plus 27. Finally, it is safe for me to add. So again, this is just coming along for the ride for now. 10 plus 27 is going to give me 37. All right, so that's done. Next, I've got to deal with the outside and what takes precedent. I've got multiplication, exponent, and I also have addition. The exponent takes precedence, so this becomes 3 times 16 plus 37. Multiplication is now important. 3 times 16 is going to be 48 plus 37. So now I'm going to add these guys together, and my answer is 85, if I'm not mistaken. All right, so we can evaluate expressions, we can evaluate algebraic expressions when we've got the ability to substitute, and I hope that felt good. And every time, we're always bringing our PEMDAS game, always bringing our PEMDAS game. You're going to bring your PEMDAS game for life, so make sure you memorize it and make sure you know how to use it correctly. I cannot wait to see you. Let me know if you have any questions. I will talk to you soon. Bye-bye, guys.